Hi there, everyone. We're back, and it is my absolute pleasure to introduce to you the Dean of the Faculty of Engineering, Professor Elizabeth Croft. Professor Croft, how are you?
I'm very well, Jamie. Good to be here and have a chance to chat with everybody.
Oh, thanks so much for giving us your time. It's really great to see you. Look, we talked previously, got some questions up. I think, it's always great for prospective students to hear from the person that's running our show. And I was just wondering if I could ask you a few things, including what initially got your interest in the field of engineering.
Sure. Actually, a friend of my family shared with me the drawings, the CAD drawings for the Boeing 767. And that was my first introduction to this is the kind of thing that engineers do. They design airplanes. And I thought it was absolutely fascinating to see that you could use math and physics and drawing to create something like the Boeing 767. And so that was my first sort of introduction of what this was about. This was mathematics and physics and science and design. And that was the piece I didn't know about, this design, this idea that you could create these things and build these things, across so many different areas, and captured my imagination.
Were you a teenager or?
Yeah, I think I was a young teenager, probably. It was a little while ago, but I just really remember, kind of taking these, there was big D-size drawing paper with the plans of the different parts of it, and he had just sort of said, "Have a look at these." And I took them home and I looked at them, and I was like, "Well, I have no idea what this means, but it looks really cool."
But it looks really cool. Yeah, that's terrific. So you're originally from Canada, but you've been here a few years now. Do you want to tell us about the differences between Canada and Australia?
Actually, there's more. Well, Australia's warmer.
Yeah, that's true.
But actually, there's a lot more similarities than differences, I think, especially from an engineering perspective. Both large countries, landmass wide, smaller population. Canada's cold in the middle, Australia's hot in the middle, but both big. So big industries that are very, very common, and a big interest in tech, which is also very common. So yeah, a lot of similarities, and also very interestingly, both highly international, multicultural countries, but with a common sort of history of where they've come from.
Yes,
and both very friendly.
Yes, absolutely. I've had the pleasure of going, and I feel almost at home when I'm in Canada. But the environment, of course, is very, very different. But a similar economy as well, resource rich, of course.
Yes, absolutely.
Yeah. So your area of specializations is robotics, and in particular, the way that humans interact with robotics. It's a very complex process. You've used examples such as the way we don't even need to think if I pass you a bottle of water. Do you want to just sort of walk us through some of that stuff that, is your area, please?
Sure, be happy to. So, the short history of robotics really started in manufacturing, and for much of the sort of late part of the last century, robotics have been in cages. So you see robots doing vehicle manufacturing, welding, painting. That was all robots in cages, and programming them, and a great deal of work done in the design of both the mechanics of the robots, but also the control and the software architecture. Right. The future of robotics, though, is robotics that work with people. So we've sort of kind of got to where robots are really good on their own in a cage, but where the exciting part of robotics now is in service robotics, personal robotics, self-driving cars, delivery robots, robots that come into our home So we already do have, Roombas that clean our floors and things like that. But the thing that allows these robots to be successful in all of these places is whether they can be easily used by non-expert users. Like,
right.
your regular person on the street, if they want to use this robot, it has to be understandable. It has to be easily instructed. And so I look at how we design the algorithms and the construction of robotics so that they can be easily used by general users.
Right. Okay. And obviously, the university and through your interest in the way that robotics is emerging, we have made some development and investment in the field of robotics through the development of our lab. Can you talk to us a little bit about what that is and its capabilities, please?
Sir, I'd be absolutely delighted. So we have developed a new lab called Monash Robotics. It has a big group of academics and early career, senior academics, early career researchers, PhDs, and a whole bunch of actually undergraduate students who are all working in this lab. And we're developing new kinds of robots. There's a group working on agricultural robots. There's a group working on healthcare and home care applications. There's groups looking at robotics for manufacturing applications, where it makes it easier for the robot, the users to use robots in manufacturing applications, and also applications in robotic surgery. So there's a wide range of opportunities to do research in robotics at Monash. And of course, underpinning that, we have our fabulous new robotics and mechatronics undergraduate degree.
Yes.
And that's a great opportunity for students to be introduced to this fast growing field. And then through their projects, even explore more deeply. And that's just really quite a fun thing for us to have.
Yes, that's right. We had the mechatronics, but now it's being coupled with robotics. And of course, that gives students some more depth. And of course, there are a couple of streams there, aren't there?
So we have the one focused towards automation, and then we have the one focused to AI. And I think that's both are very quite interesting and exciting. And certainly the combination of robotics and machine learning and artificial intelligence is really a big part of the future of both robotics at home and robotics in manufacturing. It's really important to have that view across that. So it's quite an exciting time to be in this field.
It is an exciting time. And of course, you did mention assisted surgery and the like. We have a new biomedical engineering specialization, and that must have some crossover as well into the field of robotics and mechatronics, and of course, electrical, mechanical. And we've got the Monash Vision Group that's proceeding to human clinical trials for the development of their bionic eye. This is an exciting time for you and for us.
Absolutely. And I do agree that there are many crossovers, and that's why engineering is so interesting, and why actually I think it's really important that we have a common first year where students can come in and explore what the different possibilities are and see what they are interested in. And the other thing I think is really important for students that we've introduced is so many of the engineering minors. So a student can do a degree with us in one area, and then they can pick up an extra minor that can help them build depth as well as breadth in areas. And I think that's a real plus and feature of our undergraduate program.
Yeah, that's right. I'm just going to put the link up to the engineering minors page. I am very excited for the faculty with the delivery of these new minors, because you're right, they that intersection between technology and engineering is really manifest in that new range that is available. And it really adds a lot of value for students that want to take on that option. Of course, it is an option. They can continue to take their electives in their area of specialisation, but if they want to top up and get a minor, that'll be on their transcript, then they have this new range that we offer now. So you obviously are a great exponent and champion of women in the field of engineering. What would you, what sort of messages would you like to communicate to our young prospective female students that are looking at STEM, but who I know you want to have them really look closely in engineering? Yeah.
Yeah. So one of the things I think is pretty wonderful about the future of engineering is I think that it is a future where women are very much welcome and highly valued. And I think that people don't really realize that a huge part of engineering is actually designing for people. Because fundamentally, everything that we do in engineering is to build devices, to build cities, to build environments, to do things that benefit people. And I think that's something that's very attractive to women, is that I always say, if you want to make a difference in this world, if you want to save lives, if you want to make address our climate issues, our food security issues, our water issues, if you want to make that kind of difference, then engineering is the place where you can make a huge positive difference, because the solutions that we need, if we're trying to deliver how many billion doses of vaccine to a planet right now, you need a lot of engineers to build a lot of factories to produce a lot of little glass bottles and a lot of vaccine going into those little bottles. We need all that production, and that's done by engineers. If we think about when we turn on the tap every day and there's clean water running out of the tap, that is brought to you by engineers who are, designing the water collection, purification, and delivery to your home. If you think about every time we use a telecommunication device, we use our phone, we use our computers, every time we get on the metro, anything that you can touch, and all the clothes that you wear, those are engineered products. And if we want to make them clean and recyclable, if we want to have a circular economy, we need people, young women and men who are switched on and smart, who can help us solve those problems. But it's the engineers that are going to provide the technical solutions for a sustainable future.
Absolutely. Absolutely. Now, I have a couple of attendees who have got their hand up, but I'm asking them if they can put their question in the chat, and then we can respond to their inquiry. So please do that. Borna and Prisha, we appreciate your involvement, but if you could put the questions in the chat, that would be really terrific for us. We have been talking about the capabilities of engineers, and I know for the faculty we're looking at moving those capabilities along with things like the new robotics lab, and also some bigger projects around Monash University and a technology precinct. Could you maybe just make a few comments about what that is looking like, please?
Certainly. Well, we are doing some big projects at Monash. So one of our big commitments is net zero. So we will be net zero by 2030. And that means we're investing in microgrid, we're investing in electricity grid, we're investing in windmill farms, and we're doing a lot of research and work right on the campus to deliver the grid of the future. because it's a grid that has to handle varying load when the sun shines and then doesn't shine, when the wind blows and doesn't blow. So we have to develop new kinds of batteries and new kinds of storage. So we're working in hydrogen. That's another way we can crack sunlight, crack water using sunlight and create hydrogen that we can then use to fuel when we can't use electricity or battery. So these are the kind of projects we're working on. We are building a hub for where we can bring in new companies and startups, and that's an exciting piece. So we already have a fantastic co-op program where you can do internships with companies, both companies that we've started up on campus, but companies all around Australia. We even have co-op internships in China. So we're becoming quite international in terms of that. And so there's these opportunities to do those things, but also great opportunities on our campus, in our makerspace, in this new hub, with our generator, which is the place where we develop startup companies.
Right.
These are all opportunities for students to get job-ready experience. And, the demand for engineers in Australia has never been higher.
It is looking good, isn't it, on the job front?
It is the right time to be an engineer.
Yes.
Because whether it's manufacturing or, and robotics and all of that, or if it's, the smart grid, agricultural engineering, there's so many different places in terms of clean energy, in terms of biomedical. There's just so many opportunities. And one of the things I love to do at graduation is I ask every student what they're going to do next.
Yeah.
And it is amazing that, they all have jobs. They're all going off somewhere to do something fantastic. So, the demand is there for engineers right now. So this is the best time ever to be an engineer in Australia.
It is a really great time. I think a part of the issue is that we're not quite producing enough of our own engineers, and so that places the demand equation in the favour of those that do come and study engineering. That's absolutely right.
That's right.
Now, you brought the co-op model. It's a bit of a unique program. There are other internship opportunities that we've developed across our faculties and in engineering at Monash, but co-op is quite a unique one, and I think it's a model that is very popular in North America. Do you want to tell us just a little bit about that, please?
Certainly. So co-op has been running in North America since the early 1900s, and it's a model where students, kind of like in the UK, they call it the sandwich model, but basically in between study, you can do 3 months, 6 months, or a year of paid internship with a company. And so we work with companies that are interested in hiring students to work with them. And we help students prepare for those opportunities, learn about how to write your CV, and that you don't wear white socks with black pants when you show up for your interview, and all the other important things, just how what it is like to work in an engineering role. And one of the things I think that's so important about co-op, and I did co-op as an undergraduate student, is it helps you discover what you're good at. It helps you understand what engineering is going to be like when you graduate. You can try before you buy, see which areas you're interested in. And then when you come back to the university, maybe there's different electives that you're thinking, oh, I really like this part of my job, so I want to go maybe deeper into, for me, I wanted to learn more about computing, and I wanted to learn more about software development because I did a co-op internship in a place where I was working in robotics, and it was clear to me I needed to learn more about that. So yes, these kind of things help you discover that. I think it also starts you developing a relationship with employers. And so that is a good thing as well.
Yeah, that is a really good thing. And of course, the process requires students to make an application and they have to go to interview. So it's kind of while they're studying, mimicking what it's going to look like in the real world once they do graduate anyway, right?
Absolutely. It's learning on the job and learning about the job while you're in school.
Yeah, that's right. And maybe just one other thing to touch on before we wrap up. A couple of questions in here as well. But I think the teams and clubs are also a great way for students to directly engage and connect to industry. Is that right?
Absolutely. So we have the most successful student design teams in Australia. So we have 16 different design teams, everything from the Monash Motorsport to the human-powered vehicle and the high-powered rocketry and the Nova rover, and the list goes on.
Yep.
And all of those teams are student-run. Basically, they're businesses. They are student-run companies that go and compete in competitions with universities and other students around the world. And the fantastic thing about the Monash student teams is they compete and they win. These are very, very successful student teams. It's a great way, again, to get hands-on, job-ready experience. You can join a team from first year. They're always out recruiting. And they will show you the ropes. So you don't need to know how to, design a rocket before you join high-powered rocketry.
Correct.
They will train you on how to do that and how to do that safely, which, believe me, is very important. So this is a fantastic value add and opportunity for students. You make friends. These are friends you will have for life, and you will have such a fantastic experience. And even over this COVID period, our students have still been rocking it and winning both on the online competitions, and we've even managed in different times to be able to get out there and compete on the campus and at other campuses, and we will again soon, I know. So this is something that's just been fantastic and continues to be fantastic for our students.
I think, yeah, when we, in my role, of course, looking at what we offer and then comparing us to other universities, I think it's fairly safe to say that in terms of the teams and clubs, their level of professionalism, the support that the faculty gives them to operate like proper business units is unrivaled. We've got a couple of questions that have come in, and I was just wondering if you might want to have a look at them as well, Professor
Sure.
Croft. We've got a question about computing engineering. Is that a good path in Australia? Probably software engineering might be a better way for us to couch.
Huge opportunities. I've been talking to CEOs of software companies, and they just cannot get enough software engineers. And so it's a great opportunity, and there's been some fantastic companies that have come out of Australia, like Atlassian, and a number of other ones. And so there's great opportunities for people who are interested in that. And so Afterpay, there's another one that just went, they got bought by Square. So, and so there's some great, but there's a fantastic company called Sierra Systems, which was founded by a Monash electrical and computer systems alum. And I was, about 4 weeks ago, just before we went into our current little stay-at-home order, I had dinner with him, and he was telling me that he's just always looking for people. Yeah. And so this is somebody who's graduated from Monash, started a very, very successful company. It's about a couple hundred people. And, now he's hiring Monash grads. So these are the kind of opportunities we have.
Absolutely. There's just one final question here, the difference between engineering bachelor degrees being offered at Monash compared to TAFEs. So the Monash degree is going to give students the professional accreditation recognition. Is that right, Professor Croft?
That's right.
Whereas the TAFE might be a level lower.
It's a different credential. So the Monash engineering degree is giving you a Washington Accord professional degree that is going to allow you not only to work in Australia as a professional engineer, but allow you to work once you've got your experience, but would also allow you to work and be recognized across Canada, the US, Europe, France, in Asia, in China. It's an internationally recognized engineering degree at the professional level, whereas a degree that at a TAFE level is a lower level. It's more like a technical based degree, and it has a different accreditation.
That's it. So, any last words before we finish, Professor Croft? Because we are on time now. But a final message to our prospective students, please.
Yeah. Well, actually, there was a question from Priya about biomedical engineering.
Yes, that's right.
And I just sort of wanted to touch on that.
Yeah, please.
So biomedical engineering is a fantastic opportunity, and actually in Melbourne is one of the best places to do biomedical engineering, because we have a huge demand here, because we have such great hospitals, so many people developing medical technology, and we have a wonderful student club called Monash Young Medical Innovators. Yes. And they're working with our clinicians to develop new technology. And of course, here in Melbourne is where the cochlear device was invented. And of course, we have the work on the bionic eye, but there's so many other opportunities for biomedical engineering here. But to wrap it all up,
yes,
it is a fantastic time to be an engineer. And really, the sky is the limit. There are so many opportunities. When you come into first year, you can see all that we have to offer. You can learn, and find out what you would like to do. And so I really can encourage you, have a chat with Jamie and our other colleagues to find out more. We're excited to have you come and study with us here at Monash, and we just can't wait to see you.
Brilliant. Thank you so much, Professor Croft. We really appreciate your time. I'll just add before we sign out that Yan Wong has made a very good point to any of the attendees, prospective students. You can jump back into the booth. And of course, there are plenty of people to answer your questions about specializations, about teams and clubs, co-op and the like. Professor Croft, thank you once again for your time.
Pleasure. Take care. Thanks very much, everybody.